Hello everyone. In this class, we'll learn about classification of monohydric alcohols in that compounds containing sp2OH bond. See sp2OH bond. In previous class, what we have learned? We learned about compounds containing sp3COH bond. In that we learned then OH directly attached to alkyl group and OH group directly attached to this allylic, and third one we studied about benzylic, right? It's about a compound containing sp3COH bond. In this class, let us learn about compounds containing sp2OH bond. That is, OH group is here. OH group is directly attached to the sp2 hybridized carbon atom. sp2 hybridized carbon atom. Here we can see two types of alcohols. One is vinylic alcohol. We already studied, right, this kind in a previous lesson. Vinylic alcohols. What are vinylic alcohols? OH group is directly attached to the vinyl group. What is a vinyl group? That is directly attached to carbon-carbon double bond, right? OH group is directly attached to carbon containing carbon-carbon double bond. Allylic OH group directly attached to carbon, sp3 hybridized carbon atom, which is present next to the carbon-carbon double bond. Okay, I don't know definition here. Vinylic means directly attached to carbon containing carbon-carbon double bond. Allylic is directly attached to carbon atom, which is present next to the carbon-carbon double bond. Don't get confused. Vinylic alcohols. Second one is if OH group is directly attached to aromatic ring. Okay, if it is directly attached to aromatic ring, now what will get? The aryl group. If this is sp2 hybridized, and here also this carbon atom is a sp2 hybridized atom, and to that if OH group is attached, then are called phenols, right? Then results in the formation of another class of compounds called phenols. That is about the classification of monohydric alcohols. First one, compounds containing sp3COH bond, alkyl group, allyl, benzylic alcohols. Second one is compound containing sp2COH bond, sp2COH bond, sp2COH bond. In that, vinylic alcohols in which OH group directly attached to carbon, that is vinylic carbon, and here OH phenols, that is OH group is directly attached to the sp2 hybridized carbon atom of a benzene ring or aromatic ring or aryl group or arenes, right? Then are called phenols. This is about classification of alcohols and phenols. Now let us move to the next topic, that is classification of ethers. Okay, classification of ethers. We already learned about classification of alcohols and phenols. If you want other example, you can substitute the ortho or para position by other functional group, and you can take the other examples for phenols. Now classification of ethers. First classification, that first one is simple or symmetric ethers. Simple or symmetric ethers. What are simple or symmetric ethers? That is, if the alkyl or aryl groups are attached to the oxygen atom are same. That is, if the alkyl or aryl groups attached to the oxygen are same, then are called simple. I'll write one example, general example. If alkyl group or aryl group attached to the oxygen atom. Here if I take these two alkyl groups, if these two alkyl groups are same, alkyl or aryl groups attached to the oxygen atom are same, then are called simple or symmetric ethers. This is symmetric ether now. Or aryl group, any aromatic ring, R O aryl compound, then are called symmetric. For example, I'll write example for this. I'll take methyl group O and CH3. So to this oxygen, two groups are attached which are same, then are called simple or symmetric ether, right? Dimethyl ether. Next, second one is complex or unsymmetric ethers. Okay, complex or unsymmetric ethers. See, what is complex or unsymmetric ether? R O R dash. I'll write it as R dash. R and R dash are different. Now it's nothing but alkyl or aryl groups attached to the oxygen atom are different, then are called unsymmetric ethers. For example, if I take a methyl group O and here it is a ethyl group, then these type of kind of compounds are called complex or unsymmetric ethers. So ethers definition, you know, ethers are nothing but oxygen containing alkyl or aryl group. Oxygen directly attached to alkyl group or aryl group. Or one more definition is, if I'll take one methanol, if we replace hydrogen of alcohol by alkyl or aryl group, this is alcohol, yes or no? This is alcohol, methanol, right? If we replace hydrogen of alcohol by alkyl group, then results in the formation of a ether, right? Alkyl group, if I replace alkyl group, if I take it as a CH3, then it results in the formation of alcohol. Or if we replace hydrogen of alcohol by aryl group, C6H5, benzene ring, right? Then also it results in the formation of ethers. Or if we replace from phenol, that is C6H5, if we replace hydrogen atom of phenol by alkyl or aryl group, then also it results in the formation of ethers, right? In two ways you can define this ethers. This is about classification of ethers. One is simple, symmetric, and complex or unsymmetric ethers. So far we learned about classification of alcohols and phenols as well as ethers. So don't forget, it's a general formula. Whenever you see aliphatic with OH, alcohol, aromatic with OH, directly attached, it must be directly attached like this. It is phenol. We cannot say this as a phenol. It's a benzylic alcohol. Note the difference. Phenol means OH group must be attached to the benzene ring directly. to this sp2 hybridized, directly attached to benzene ring. Here it is a alcohol, benzylic alcohol. So aliphatic alcohols, aliphatic hydrocarbons containing OH are alcohols, aromatic OH phenols, and oxygen atom attached to two alkyl groups alkyl groups or aryl groups are called ethers. It's about classification and definition of alcohols, phenols, and ethers. Okay. Next is next topic is nomenclature. How this how can we name alcohols, phenols, and ethers? You already learned these in your previous classes, in your first PU, and let us discuss in detail. Okay, nomenclature. First, we'll see the nomenclature of alcohols, both in IUPAC system of nomenclature as well as common system of nomenclature. See, remember, IUPAC system of nomenclature is very, very important. So just to go through your first year note, there we learned many rules applied while naming these compounds, right? Organic compounds. Now let us see alcohol. In common system of nomenclature, alcohols are named as, first we have to write alkyl group, followed by alcohol. Okay, I'll give example and explain. First we'll write alkyl group followed by alcohol. In IUPAC system of nomenclature, here we substitute, in IUPAC system of nomenclature, we substitute E of alkane or replace V of alkane we replace E of alkane by all. Okay, or we substitute E by all, we replace E by all. It's about IUPAC nomenclature. If there are more than one alcohol group is present in a compound, okay, if there are more than one OH group is present, then how we name? We use multiplicatives, right? What multiplicatives? Like di, tri, etc. Okay, and position of those OH group and position of OH group is represented by numerals or locates, right? 1, 2, 3, etc. Is about nomenclature, UPSC nomenclature of alcohols. And one more thing, if there are more than one OH group, then we will retain, okay, in this case we will retain E of alcohol, right? E of alkane, we will retain E of alkane, and at the end we will add which one? All, right? Here we will retain in a polyhydric alcohol. Remember, polyhydric alcohols retained, E is retained, and ending is all. Okay, just remember, here monohydric alcohol, we replace E by OL, all, right? Here it is retained in a polyhydric alcohol, and multiplicative are mentioned by di, tri, etc. and position by 1 to 3. I will give few examples, then you will come to know. For example, one I will write here, alkane. I'll take one example, simplest, that is CH3OH. Right? In common system of nomenclature, we name it this compound as a alkyl group followed by alcohol. Which alkyl group is present here? Methyl group, right? Methyl and alcohol, methyl alcohol, right? In IUPAC system of nomenclature, what I said? If it is monohydric alcohol, only one OH group is there, hence we should replace E by all. That is, alkane is methane, we should replace this E by all, right? Methanol. And for this I will give one more example, CH dihydric alcohol or polyhydric alcohol, CH2OH and CH2OH. How can we name in this IUPAC system of nomenclature? In IUPAC system of nomenclature, we can name it as ethane, right? Two what carbon atoms are there, hence ethane. At what position all groups are there? In first and second position, that is 1,2 diol, right? 1,2 diol. So it is this is about nomenclature of alcohols. We will see one by one by taking few examples which is present in your textbook. Okay. First one, compound. Next is a common name. Next column is a IUPAC name. Let me write first example, that is simplest alcohol, that is CH3OH, and common name of this compound is alkyl alcohol, that is methyl alcohol, right? And IUPAC name of this compound is what? E is replaced by all, that is methanol, right? I'll write next compound, that is CH3, CH2, CH2OH. See, how many carbon atoms are there? 1, 2, 3, right? Those rules you know, right? There is a parent carbon, it should contain some functional group should get a least number, etc. Just go through that. And here 3 carbon atoms are there, hence it is a propyl alcohol and it's a normal chain. Here you cannot see any branches, right? Hence it is N-propyl. Okay, N-propyl alcohol. And IUPAC name, it is a propanol, right? Propane is replaced by all, propanol, or propane 1 all, one and the same. It is OH group is present in the first position, hence no need of mentioning propane 1 all as. Next is another compound, CH3 here letter OH and CH3. It's clear for you. Okay, CH3, CH3, and to this carbon OH group is attached. See, here 3 carbon atoms are there, here also 3 carbon atoms are there. First one is N-propyl alcohol. Now what about this compound? This is not N-propyl. Why? It has a branch, or you can write it as same compound. You can write it as CH3, CH3, and to this carbon OH is attached, right? We cannot call it as a normal OH or N-propyl, right? This is as we know iso, right? Isopropyl group is there. Hence, it is a isopropyl alcohol. If in previous lesson, if nomenclature is clear for you, then it will become very, very easy, right? N-propyl alcohol, propyl group is there. And IUPAC name same. I'll take 1, 2 and 3. 3 carbon, 1, 2, 3 parent chain. To second carbon, OH group is attached. Hence, IUPAC name is propane to all. Propanol, right? Propane to all. Next, one more example. CH3, CH2, 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 OH. Okay, 1, 2, 3, 4, 5. Now, it's a normal chain, right? How many carbon atoms are there? 4 carbon. Hence, the name of this compound is N-butyl alcohol. And IUPAC name of this compound is butanol or butanol, right? Or butane 1 all. Here also propane 1 all. You can write. One more compound, CH3, CH2, now, right, name this compound. Try to name. See, 1, 2, 3, 4. 4 carbon atoms are there, right? But here, this OH group is attached directly to the primary carbon atom. But this carbon atom is now secondary, right? Here it is primary carbon atom. Here this OH group is attached to secondary carbon atom. Hence, name of this compound is a secondary 1, 2, 3, 4, right? Butyl alcohol. Right, here we, even though this is secondary, we are not using secondary, right? It's a smallest. Here it starts with the iso. I have explained this in a previous class, previous lesson. And here it is a secondary alcohol. Secondary butyl alcohol. This OH group is attached to secondary carbon atom. Right, it is not iso. When we will write iso, there must be iso. This group must be there in the compound. I will give one example. We'll see, discuss in that. And numbering 1, 2, 3, 4. Functional group should get a least number, and longest chain is considered as a parent chain, right? And name of this compound is a butane to all. Butanol 1, 2, 2 only. OH group is present, hence butanol, butane to all. I write one more compound, CH3, CH3, listen, CH3, CH3, and CH2, OH. Let us see this compound. Here 1, 2, 3, 4. 4 carbon atoms are there, and here OH group is attached to primary carbon atom. Right, this is primary. Why? Further attached to one more carbon atom directly. And you can observe that here you can see isopropyl group, right? While writing iso as prefix, there must be this group. Yes or no? Hence, name of this compound is iso. Common is iso. How many carbon atoms are there? 1, 2, 3, 4. Isobutyl alcohol, right? Isobutyl alcohol. See the difference? N-butyl alcohol, secondary butyl alcohol, isobutyl alcohol. And IUPAC name, have to consider longest chain. 1, 2, 3, or straight chain will consider 1, 2, 3, right? And second position is methyl group is there. 1, 2, 3, third carbon, and second position methyl group is attached, hence 2 methyl substituent, and it is butanol, right? 2 methyl butane 1 all. It is IUPAC's name of this compound, and see the difference between all 4 compounds. That is very, very important. Identification is very, very important. Next, I'll write one more compound. You go through these in your textbook, it is there. CH3 and OH. Look at this compound. Here, see, OH group is attached to carbon atom, which is directly attached to 3 more carbon atom. Hence, this carbon atom is tertiary, right? This is tertiary carbon atom. Hence, name of this compound, common name of this compound is tertiary. Tertiary. How many carbon atoms are there? 1, 2, 3, 4. Tertiary butyl alcohol, right? IUPAC system. In IUPAC system, 1, 2. If we consider this 2 carbon atom, or 1, 2, 3. Longest chain is a 3 carbon atom chain. Hence, I will consider this as a longest chain. 1, 2, 3. IUPAC name of this compound is a second position. Methyl group is there. Hence, it is 2 methyl. See, at 1, 2, 3, 2 methyl butane. At a second position, all is there, right? 2 methane butane 2 all is the IUPAC name of this compound. See, all 4 compounds containing 4 carbon atoms, but these all are different compounds. About nomenclature of tertiary compound. Next, last one, which is there in your textbook, is like this, right? 1, 2, 3, 4 OH, and here it is CH2OH. No need of writing here. You can write here also one and the same, directly attached to OH group, carbon atom. Now, name of this compound. Common name of this compound is glycerol. Okay, just remember the structure of glycerol. You are familiar with glycerin and all. It is glycerol. And IUPAC's name of this compound, as I said, in polyhydric compounds. How we name polyhydric compounds? Polyhydric, nothing but 2 or more hydroxyl groups. Here first we will retain the E of a parent chain. Parent chain containing 1, 2, 3. 3 carbon atoms. Hence, it is parent chain is propane, right? Propane, and we will retain this E of a propane. We will not replace with the all here. Propane, right? And OH, 3 OH groups are attached. Hence, multiplicative is tri, and it is all. At what position these OH groups are there? 1, 2, 3. Therefore, name of this compound is propane 1, 2, 3, right? 1, 2, 3. How many all groups are there? 3. Triol. Propane 1, 2, 3. Try all. This is about nomenclature of alcohols. Just remember, in common system, alkyl alcohols, and IUPAC system, you should replace E by all, or in polyhydric compounds, we should retain E and ending with the all, and multiplicative like tri, di, etc. are used, and position is represented by numerals, right? Thank you.